Okay, now let's look at limits of rational functions. So remember that a rational function is of the form f of x is equals to p of x divided by g of x, where our g of x down here is not equal to 0, because when the g of x is equal to 0, it means the problem is undefined. So we said if we have a case wherein the g of x is not equal to 0, then we can use the property of limits that has to do with the quotient property, the limit of the numerator, which is p of x, as x approaches some a, divided by the limit of the denominator, g of x, as x approaches some a, right? Now, this occurs, like we said, when g of x is not equal to 0. But there will be some problem, there will be some rational function of which g of x will be equal to 0. From the beginning, when you try to apply the limit, g of x will be equal to 0. So based upon the fact that we experience problems wherein our denominator expression from the beginning of the problem equates to 0 when we apply the limit, so we try now to bring in other methods to avoid that, case wherein the denominator will immediately go to 0 when you apply the limit directly. So we want to involve like 4 distinct methods in solving a limits involving rational functions. 4 distinct methods. So the first method will be the direct substitution. Now, the direct substitution works for cases that the denominator is directly not equal to 0 when you apply the limit. So the next one has to do with the factorization method, the substitution change of variable, and the standard limits. So I'm going to discuss them one by one. So let's first start with the direct substitution. So we said the direct substitution method works for problems wherein our denominator of the limit is not equal to 0. For example, find each limit So the first example says the limit of x squared plus 1 all over x plus 1 as x is approaching 1. Now, when we apply the limit within the denominator, meaning it will replace this x now with 1, we are not going to get 0 within this denominator. So that is to say, our denominator expression is not equal to 0 when we apply the limit. So we can now use the property if we wish to, though the property at times is a kind of delaying method. So we can use the property x squared plus 1 as x is approaching positive 1 divided by the limit of x plus 1 as x is approaching positive 1. So we now apply the limit, now replacing x with the value, which is 1 squared plus 1, all over 1 plus 1 is just equals to 2 all over 2, which is now 1. So directly from here, you could just apply the limit. When x is 1, you have 1 squared plus 1 all over 1 plus 1, which is just 2 over 2, it just equals to 1. So you don't have to go this long route, unless you were asked to evaluate or to solve the limit using the properties of limits. So you see, this is a kind of direct substitution. Now let's look at the next one. If you have problems of the form p of x divided by g of x, right? So let's assume we have x plus 5 divided by x minus 3 as x is approaching minus 3. So test, put the minus 3 down here. If you put minus 3 right here and you have a minus 3, can this give you 0? No, because minus 3 and minus 3 is equals to minus 6. So because the denominator is not 0 now, we can just apply the limit using direct substitution. So now we replace x now with minus 3 plus 5 divided by minus 3 minus 3. So this now is just equals to positive 2 all over minus 6. So 2 into itself 1 times, 2 into 6 3 times. So you will just have negative 1 over 3. So when x is approaching minus 3, the limit of this particular rational function will be equals to minus 1 over 3. So we do the next one. So let's say you had the limit of x squared plus 3x plus 2 all over x minus 2 when x is approaching minus 2. So the first thing you do whenever you see a rational limit or limits of rational functions, the first thing you do is to test the limit within the denominator. If the testing within the denominator gives you 0, then you think of how you can use other methods. But if the direct substitution within the denominator did not give you 0, it means that limit can be solved using direct substitution method. So let's test in this denominator. If we put minus 2 right here, you have minus 2 minus 2. Can this give you 0? No. So we don't have to use any other method. We just use the direct substitution method. So we replace x now with minus 2 all squared plus 3 times minus 2 plus 2 divided by minus 2 minus 2. So minus 2 times minus 2 is positive 4 minus 6 plus 2 all over minus 2 is minus 4, and this now just gave us 4 minus 6 is minus 2 plus 2 all over minus 4. So minus 2 plus 2 is equal to 0 all over minus 4. 0 divided by minus 4, it is 0. Now when 0 is in the numerator, it is accepted. But if 0 now is in the denominator, it is not accepted because 0 should never be within the denominator. So this is the answer. So as x is approaching minus 2, this entire function now goes to 0.